factorising any expression really means writing it as a product of terms. So if you think of the factors of 24, we sort of write that as 6 times 4 or 2 times 3 times 4. It's a product. It's a product of terms. So that's what we're looking to do here. So the first type here is we want to write it as a product, so we look for common terms. So clearly in this case, 9 is common to both 9 and 81. X is common to both x squared and x, so we can take 9x out as a common term. Second example here, where we can see 7 is common to both. There's an x in both, and there's a y in both. So if we look at the first term, the only thing we don't have represented is that squared. So I'm going to have to put an x in. I've got a minus. 7 goes into 35, so that's 5 times. I've got an x term covered, so that's okay. I don't have the squared term there, so I'm going to need a y. So there's my 7xy times x minus 5y as a product of terms. Type 2, okay, we can look to try and group the terms. So I guess the key to that is thinking that if grouping is going to work, if we look at all those coefficients, 1, 4, 3, 12, well, 1 by 4 by 3 is 12. So they're sort of like the factors of each other. So that's the little clue. But if we look at the first two terms, there's an x squared common to both of those. And so I can write x plus 4. And there's a negative 3 common to both of those. I can also write that as an x plus 4 because negative 3 times x is negative 3x. Negative 3 times positive 4 is negative 12. So now both of those terms have an x plus 4 common. So if I take that out the front, I get an x squared minus 3 there. Now in actual fact, when we get to our difference of squares, we could actually write that as x plus 4, and we'll have that as an x minus root 3, x plus root 3. So that's, I guess, our fully factored form, I should say. If we come to the type 3 ones, we are talking more specifically about our difference of two squares. So my difference of two squares apply if I have one term squared minus another term squared. So it's an x squared minus anything really, because as we saw up here, that 3, we can just make that as root 3 squared. So if we have a look at these examples, first step is, well, since 3 is a common factor to both of those, I could take that out, 3x squared minus 25. And now I've got x squared minus 25, which I could write as x squared minus 5 squared. And from my difference of squares, 3 times x minus 5, x plus 5. Okay. Similar for the next example, it's less obvious, but again, if we consider this expression here as just one term, I've got a term squared minus a 16y all squared. So we could express that as x minus y all squared minus 4y all squared. One term squared minus another term squared, which gives me x minus y minus 4y, x minus y, minus y plus 4y. So simplify the bracket if we can, and we get minus y minus 4y is x minus 5y, and I get minus y plus 4y, so it's x plus 3y. So that's my difference of squares. Now my factorising our quadratic expressions is what we typically learned last year. So the cross method, if we think about the factors of x squared, they are x and x. The factors of 3 are just 3 and 1. So remember, we aim to come up with a cross that gives me 4x. So in this case, it's not going to matter the order. X times 1. So if I go down there is x, x times 3 is 3x. If I add them up, I get 4x, which is the middle term. So that factors to x plus 3, x plus 1. So if we have coefficients at the front, ideally we can simplify first, factorise first. So 3 goes into all of those. So if we come over here, if I take 3 at the front, I'm going to get x squared plus 5x plus 6. So it's the same sort of thing, isn't it? So factors of 6 that add up to 5, which is just 3 and 2. So that's going to be x plus 3, x plus 2. Now if we come to our final example over here, again, 3 will factor, oh, it won't actually. 3 doesn't go into any of those. So 6, 13, and 15. So there's not going to be anything factor there. So we'll use our cross method. So let's have a look at a 3x and a 2x. We've got to be trial and error here. 3x and 2x and 15 typically is going to be a 5 and 3. So let's have a look if we can manufacture a 13 out of this. So 3 5s are 15, 2 3s are 6. That's not going to add or subtract to 13, is it? So if we, and I've got the advantage of a rubber, if we rub those out, and let's try a 5 and 3 that way. 3 3s are 9, 2 5s are 10. That's going to be a 19 or a 1. Again, that's no good. So those combinations don't work. So instead, we might have to try a 6x and an x. And I'm still thinking 5 and 3. Let's put a 5 there and a 3 there. I didn't put the 5 down here because 6 5s are 30 and that's going to be too big. So 6 3s are 18. X times 5 is 5. And if I subtract those, I get 13. So what do we need here? We need a negative sign. So if I make that negative 3, that makes that negative 18 plus 5 is negative 13. So that's what we're looking for. So the factors are those terms there. So the factors of that is 6x plus 5, x minus 3.